GCSE Mathematics Paper 1HR, May 2018. Okay, so what we need to do is work out the area of this hexagon. We can do this by splitting the shape up into two sections. What I'm going to do is split it up into a rectangle and a trapezium. So if I draw a line across here, you can see we have a rectangle, which is of length 20 by 14. So the area of the rectangle is 20 times 14, which is 280. And also we have a trapezium at the top. This shape is a trapezium. On the formula sheet is the formula for the area of a trapezium. It's a half brackets A plus B times H. Now A and B are the parallel sides, so you have 16 there. This side is 20, the same as the AF. So 16 plus 20 times the height. The height of the trapezium is this part here. So as you can see, the entire height of the diagram is 24, and this bit's 14, so this bit here must be 10. So you work out the area of the trapezium, and you end up with 180. Add the two areas together, and you end up with a final answer of 460 centimeters squared. Next. Calculate an estimate for the mean. The mean, you need two extra columns. One is midpoint, and the next one is midpoint times frequency. Now, if for whatever reason you are unable to work out the middle of 0 and 2, there is a way. There's a button on the calculator. Using the fraction button, you can add the two numbers together, so 0 add 2, and then divide by 2. So the middle of 0 and 2 is 1. And you can write down all the midpoints. Okay. Work out your midpoint times frequency. So 1 times 5 is 5, and then 27, and 120, and 280, and 63. What you then do is total up the midpoint times frequency column, which is 495, and divide it by the total frequency, which is 85. Now, it says calculate an estimate for the mean time these students spent doing sport. Give your answer in hours correct to one decimal place. So the time is in hours, so all we need to do is divide it. So we have 495 divided by 85. Type this into the calculator. And the answer is 5.823. Now, it's not very often you round the mean, but it does say to round it to one decimal place. So the answer will be 5.8. Next one. Reflect triangle S in the line y equals x. So the line y equals x is where the x value is the same as the y value. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, etc. So I'm going to draw this line on y equals x. Okay. And you have 10, 10 in this corner. You have to be careful with drawing a diagonal line, because sometimes the x scale goes up to 10 and the y scale will go up to 11. You just have to be a bit careful there. So you need to reflect this triangle in the line. Now, if I take each corner, this one is 1 square down, so you go 1 square across. This corner is 1, 2, 3 squares down, so you go 1, 2, 3 squares across. And finally, this corner here is 2 squares down from the line, so you go 2 squares across. You have your 3 points. You now connect them up, and that gives you the triangle. Okay, so the triangle should be there. Label the triangle R. That's great. Next one, translate triangle S by the vector -4, -6. So translate this one, 4 to the left, and then 6 down. 1, 2, 3, 4, 5, 6. You just have to be a bit careful, because it's not always the number of squares. It's only the number of squares if each unit is worth 1 square. So I chose the top of the triangle. This is the new top of the triangle. So I'm going to draw the triangle now. That should be there. Label it T. Next. Anna and Lionel share £675 in the ratio 4:5. So first of all, I'm going to work out how much they each receive. So remember, ratios in the order of their names. Okay, it says Anna and Lionel, so I will add them together to give 9 because there's 9 parts altogether. 675 divided by 9 works out 1 part. And once you've worked out 1 part, you then times it by how many parts Lionel has. So 675 divided by 9 is 75. That's 1 part. And then Lionel has 5 parts. So Lionel has 75 times 5, which is 375. And then he gives 3/5 of the share of his share to his mum. So 3/5 of his times in maths, 375. So we have 3/5 times 375. That gives us 225, which is the answer to the question. The next one, Ali thinks that the value of E will be a prime number. Is Ali correct? Right, there is a quick way to check. And what you do is you use the table mode to help you. So if we go to the table mode, enter the equation, but you can only enter it with x's. So x squared plus x plus 5. Right? And for any whole number value of n. So if we start at, say, 1 and end at a very high number, let's try 20. If you try too high, the calculator won't have enough memory to calculate it. Go in a step of 1, and as you can see, the numbers in the right-hand column are usually, well, according to Ali, they should all be prime. 7 is prime, 11 is prime, 17 is prime, 25 is not prime. So actually, Ali is incorrect. There are some values that you can substitute, which will result in an answer which is not prime. So for example, when n is 4, E will equal 25. Okay, 25 is not prime. Is Ali correct? No, Ali is incorrect. Of course, you won't get any marks unless you show some working. So this bit is fine. Next, this one. Okay, so many ways to do this. First thing to spot that this is an isosceles triangle. So this angle is also 65. Angles in a triangle add up to 180. So you can work out this one here. 180 minus 2 times 65. So that's 50. Yep. Which other angles can you work out? This one here. Angles on a straight line add up to 180. So if we do 180 minus 65 minus 38, that gives us this one here, 77. And then we can spot that there's a Z, or alternate angle. Right? So if we just go over that, Z there, alternate angles. And that means this one here is the same as this one up here. So now we know that all of this must be 77. And if part of it is 50, the other part must be 27, because they have to equal 77. So the answer to the question is 27 degrees. Next question. So the sequence goes up in 4s. So the formula starts off 4n. The term before the first term is known as the 0th term. So because it's going up in fours, just count back 4, you end up with 2. So the formula is 4n plus 2. Now, write down an expression for the n plus 1th term of the sequence. So the way that you do this is you replace n with n plus 1. So in your answer to part A, change the n to n plus 1. It's not the nth term anymore. N has changed to n plus 1. So that's what you do. You replace n with n plus 1. Brackets are essential here. When you multiply out the brackets, you end up with 4n plus 4 plus 2. And then the final answer is 4n plus 6. The next question, write this number in standard form. You write all the non-zero digits. You write a decimal point after the first one, times 10 to the power, and then what you do is you count the spaces. So 1, 2, 3, 4, 5, 6. Next one, write all the non-zero digits, 5 times 10 to the power. Now the decimal point, when you can't see it, after the 5. So we're going to count backwards this time. 1, 2, 3. Because we've gone backwards, it's negative 3. Next one. Okay, this is quite, there's a lot to read in this question. Okay, so if you read the question, it says the level of the surface of the water will be 60 centimeters below the top of the pool. I'm going to kind of guess roughly where the level of the surface of the water will be. So about 60 centimeters below. Let's just say it's here somewhere. And 60 centimeters is the same as 0.6 meters. So this part here is 1.9. This little bit here is 0.6. Okay, now what we need to do is work out the volume of water in the pool. So we can see that what we know that the volume of a cuboid is length times width times height, and they're all in the same units now. So we have 3 times 12 times the height of the water, which is 1.9. This gives you an answer of 68.4. Now the units for this are meters cubed. Okay, it tells us in the question that 1 meter cubed is 1,000 liters. If I want to convert this into liters, I then times it by 1,000. That will convert this into liters, and that will give us an answer of 68,400 liters. That's how many liters of water are in this pool. Okay. Now, the water flows in at 400 liters per minute. So 400 liters for every minute. If we divide 68,400 by 400, remember this is liters and this is liters per minute. What it's going to do is it's going to work out how many minutes it takes to fill the pool. So if we divide that, 68,400 divided by 400 gives us an answer of 171 minutes. Okay, that's because we're dividing liters by liters per minute. So it will work out the answer in minutes. However, the question says give your answer in hours and minutes. Now you can work this out quite easily. There is a button on the calculator that does this, which is the time button. So 0 hours and 171 minutes. That's what that is. Press equals, that's 2 hours and 51 minutes according to the calculator. Next question, simultaneous equations. We need the same number of x's or the same number of y's. If you times the top equation by 2, it's 6x plus 4y equals 30. And the bottom equation, just keep it the same because I've tried to make the y's the same. Okay. Now, the rule is if the signs are the same, you subtract. If the signs are different, you add. We're concentrating on the y's because I've decided to make the y's the same. So the signs are different. When they're different, you add. You must write this plus, otherwise you're going to score 0 marks on this. So you get 16x equals 32, and that means x is equal to 32 divided by 2. Sorry, 32 divided by 16, which is 2. and then you substitute this into one of the original equations to work out y. So if I use the top one, it's got 3 times 2 plus 2y equals 15. 6 plus 2y is equal to 15. Okay, so you have 2y is equal to 9, y is equal to 4.5. Next, change a speed of 72 kilometers per hour to a speed in meters per second. Okay, so 72 kilometers per hour. Now, there's 2 changes to make here. There's a change into meters and there's a change into seconds. So first of all, I'm going to change it into meters. Now, hopefully you remember this flow chart, which goes like this: centimeters, meters, kilometers. Okay. There are 100 centimeters in a meter. So to change centimeters into meters, you divide by 100. There are 1,000 kilometers, so 1,000 meters in a kilometer, so you divide that by 1,000. And if you go the other way, you would times by 1,000 or times by 100 accordingly. Now we have centimeters. Centimeters is the we don't need centimeters. Sorry, I'm going to muddled up. Okay, you want to change kilometers into meters. So what you do is you times that by 1,000. If we times that by 1,000, we get 72,000 meters per hour. So that's their equivalent. And now what we want to do is change it into seconds. If we divide this by 60, then it is going to work out how many meters there are in a minute, because there are 60 minutes in an hour. So that means we travel 1,200 meters per minute. And if we want seconds, to get from meters to seconds, to get from minutes to seconds, we divide by 60 again. That's 20. It's 20 meters per second. So you divide by 60 to work out for 1 minute. You divide by 60 again to work out for 1 second. Okay, next question. In 2016, the company made 350 cars. In the first 6 months of 2017, they made 25 cars each month. The last 6 months, they made 45 cars each month. Right, first of all, percentage increase. There's a formula for this. The formula is difference over original times 100. But what I want to do is work out how many cars there are in 2017. So we have 6 months at 25, and we have another 6 months of 45 cars each month, which gives us a grand total of 420 cars. So now I'm going to use the formula. The formula is difference over the original, which is 2016, times 100. And this gives us an answer of 20. Next. The company's income in 2017 was $500,000 more than their income in 2016. The company's income was 8% more than their income in 2016. So what it means is they made a lot of money, and their income, I've just underlined those words because $500,000 is what it's gone up by in 2017, but it's also gone up by 8%. So because they use the same words, these two are equivalent. So you can state that $500,000 is equal to 8%. Now what they earned in 2016 will be 100%. In 2017, it will be worth 108%, but they're not telling us how much it is valued at in 2017. They're just telling us what it's gone up by. So this is only the 8%. This is just the increase. What they actually made altogether must be a very, very large number, and that's what you're expecting. So the way that we do this is we're trying to get to 100% because that's what it will be in 2016. There is a nice way to introduce a middle step to go from 8% to 1%. So if we divide $500,000 by 8, divide by 8 here. You can divide by 8 here as well. If you do 500,000 divided by 8, you get 62,500. That's worth 1%. To get from 1 to 100, you times by 100. So if you times this by 100, you end up with something like this. Okay? Commas from the end, 3 spaces. So 6,250,000. That's the answer. Next. Each month, Edna spends all her income on rent, travel, or other living expenses. So we have rent, travel, or other living expenses. Rent is worth a third, travel is a fifth, and here she spends $420. Work out her income each month. So the idea is to work out what fraction living expenses is. So you know that fractions have to, all of the options will add up to a whole one. So if we do 1 minus a third minus 1/5, that gives us 7/15. So basically, $420, which is what's left in the table, must equal 7/5. So what did it say? 7/15. Okay. Now, 7/15 is worth $420. What I want to know is what a whole one is worth. Now, several ways of thinking about this. It's a bit like the previous question, but I am going to have a middle step. I want to get to a whole one. But what I'm going to do is think about it like this. Imagine you have a shape and it's divided into 15 sections. 7 of those 15 sections is worth $420. So if 7 sections are worth $420, you can work out what one of the sections is worth. And you can do that by dividing this by 7. And if you divide this by 7, you get 60. Let's have a look. So 420. Oops. 420 divided by 7 gives you 60. So $60 is worth. Remember, I've divided this by 7 to work out one of the 7, because this is worth 7 of the 15. So one of the 15, or really, you think about how do you get from 7/15 to 1/15? And the answer is you divide by 7. So if you want to get to a whole one, if you have 1/15 and you want a whole one, 3 times by 15. So 60 times 15 gives us 900, and that's the answer to the question. Next question. Simplify. So don't forget the rule. When you have a bracket to a power, you times the powers. X to the power m to the power of n is x to the power mn. So we have 2 to the power of 3, which is 8. We have e squared raised to the power 3, which is e to the power 6, and f to the power 3 to the power 3, which means you times the powers, so you get f to the power 9. Next one, we expand the brackets. Okay, you can draw the lines if you want to, like this. You're just going to be very careful with the signs here. So we have 3x squared plus 9xy minus 4xy, and then minus 12y squared. When you simplify this, if you simplify the middle two terms, you have positive 9xy, take away 4xy. 9 take away 4 is 5. So you get 3x squared plus 5xy minus 12y squared. The next one is a bit tricky, unless you know that the square root of a is the same as a to the power of a half. So you have a to the power of a half times a to the power of 1 over a to the power of negative 2. Now, when you times, you add the powers. If you type in the calculator half add 1, you get 3/2. When you divide, you subtract the powers. So we're going to do something like this. Remember, you subtract the powers. So it's 3/2 minus the power at the bottom, which is also negative 2. So you end up with a to the power of 7/2. and it says find the value of k. K is the power, so it's just 7 over 2. This next question is quite hard, unless you spot something which is quite clever actually. You have to know that 4 to the power of n is the same as 2 squared to the power of n. Now, 4 is 2 squared. That's all I've done. I've just changed the 4 to 2 squared. Now, going back to the rule at the top of the page, when you have a bracket to a power, you can times the powers. So this is also equal to 2 to the power of 2n. And because multiplication is commutative, it doesn't matter which order that you do it in. You could also write this as 2 to the power of n squared. Because when you have a bracket to a power, you times the powers. N times 2 is 2n. So all of these lines, all of these terms are equal to each other. Now, if you think about it like that, then you can write this 4 to the power of n as 2 to the power of n in brackets squared. And you can also think of the 1 as 1 squared. And when you look at it like that, you can actually see there's a difference of 2 squares, because you have 2 squares in the denominator. So when you have the difference of 2 squares, you write it like this: 2 to the power of n minus 1, 2 to the power of n plus 1. And then you can see this bracket here cancels with what's on the top here, and it leaves you with a 1 on the top. So the final answer is 1 over 2 to the power of n plus 1. It's quite tough. In the examiner's report, this question said it was one of the least well answered questions on the paper. Next question. Okay, so the first branch is 9 over 20 because it has to add up to a whole one. If you complete the structure of the tree, don't forget the labels as well. So we can write B, R, follow the same order as the previous part. So B, R, it's okay to write B, R. This is bag Y. In bag Y, there are 16 counters and 9 of the counters are blue. So 9 over 16 are blue, and then that must mean the other 7 are red. Okay, next question. Work out the probability that they are both red. That's red, red. So from the tree diagram, it's 9 over 20 multiplied by 7 over 16. That gives you an answer of 63 over 320. Work out the probability that the two counters are both red or both blue. So we've just worked out both red. So now all I need to do now is work out both blue. Blue from the diagram is 11 over 20 and 9 over 16. 11 over 20 times 9 over 16. And what we're going to do is work this answer out and then add it. So work this answer out and then add it to the previous answer, which is 63 over 320. And when we do that, we end up with a final answer of 162 over 320. Let's see if this cancels. 162 over 320. Yep, cancels to 81 over 160. Either are fine. Next question. So this is called the intersecting chords theorem. Let's take a look at this then. So I can show you this with a bit of color. You take the part outside the circle, and then also you consider the entire line. Again, you take the part outside the circle, and you also consider the entire line. Now the rule is basically red times green equals red times green. It's the bit outside times the entire length of the line. So let's have a go. It's 12, which is the bit outside the circle, red, times green. Now the green line is this part is 12 and the other part is x, so it's 12 plus x. And apparently this is equal to x times the entire length of the line, which is x plus 4. Hopefully when we expand this, we should end up with the answer. So if we expand the brackets, okay, I've written a times there, but I don't really need to when it's a bracket. So 12 times 12 is 144 plus 12x equals x squared plus 4x. If you rearrange this, so we have everything on one side, x squared minus 8x minus 144 equals 0. It's great. What you can do now, folks, is you can either use the quadratic formula. In fact, I would because of this sentence. Give your answer correct to 3 significant figures. So A is equal to 1, B is equal to negative 8, and C is equal to negative 144. Substitute into the formula, x equals minus b plus or minus the square root of b squared minus 4 times a times c. Got to be very careful here with the signs. Very, very careful. Big fraction line, 2 times a. Then use the silver calculator. So mode equation, option 3. Enter your a, b, and c. So 1 and negative 8 and negative 144. We've got 2 answers. One of them is 16.6. X equals 16. You copy down the display, remember. 6, 4, 9, etc. That's going to be 16.6. And then there's the other one, which is minus 8.64. Now, you don't need minus 8.64 because you cannot have a negative length. Okay, so you can write. It's up to you whether you write this down and say and cross it out or just not write it. So we've just figured out that x is 16.6. The question asks for the length of AC. So AC is this bit here. So I've just worked out this part is 16.6. Add another 4 onto it. So you get 20.6 as the answer to the question. So next question is a histogram. So we recall the formula for histograms, which is frequency density equals frequency divided by class width. Fern does French coursework, that's what we normally say. Create 2 columns at the end, and only for histograms, CW and FD. CW is the class width. How wide is the class interval? 0 to 20 is 20 wide. The next one is 30 wide, and so on. How do you work out FD? It's frequency divided by class width. So 40 divided by 20 is 2, and so on. Okay, it's just a case of drawing the bars now. Okay, got to make sure the bars are exactly the right width. So we start at, I'm just going to, the scale is a bit awkward at the bottom here. So each 2 squares is worth 10. Perhaps put it on mark every 2 squares. Yeah, that should be okay now. Okay then, so let's draw these bars. The first bar will go from 0 to 20 and have a height of 2. The next bar goes from 20 to 50, a height of 3. The next bar goes from 50 to 100 and has a height of 2.8. Next one goes from 100 to 300 and has a height of 0.7. And the last one goes from 300 to 350, the height of 0.8. There you go. It's now complete. Right, so next question. Now we have 2 triangles backed onto each other. quite often when this happens, we need to work out the connecting line between both triangles, SQ. We're asked to work out the sides of angle SQR. Right. This is a we're at question 18 of the exam paper now, right at the end. And it's a grade 8 to 9 question. It's not SOHCAHTOA trigonometry. It's not Pythagoras' theorem. It's going to be the use of the sine rule or the cosine rule at this stage of the paper for non-right angled triangles. So in the top triangle, I can work out the length of this side, SQ. Now we have 3 sides involved and 1 angle. When we have 3 sides and 1 angle, we use the cosine rule. It's only when you have multiple angles involved do you use the sine rule. So cosine rule is a squared equals b squared plus c squared minus 2bc cos capital A from the formula sheet. B and C are the sides which sandwich the angle. A is the other side. Doesn't matter which one is B and C, as long as they sandwich or either side of the angle. Okay, so we have a situation like this then. We have x squared or a squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times cos of 120. So if x squared is equal to that, then x will equal the square root of that. Now you don't have to type it in stages. You can just be confident and type it in one go like this. 8 squared plus 12 squared minus 2 times 8 times 12 times cos of 120. Okay, this is x squared. So then you square root this and you end up with the answer 4 root 19. So this is x, and I'm not going to round this. I'm not going to convert it to a decimal. I'm going to leave it like that. Okay, so I've now worked out this side, which is 4 root 19. We're now going to try and work out this angle. Now, we have multiple angles involved, so it's a sine rule. The sine rule is on the formula sheet, but you need to write the sine rule upside down when you're working out an angle. So it's sine capital A over A equals sine capital B over B equals sine capital C over C. So what you do is the way that the sine rule works is you pick an angle. So if I say sine 27, it will be over 9 because it's the side opposite. The issue with this is, you see, if I want this angle SQR, I need this side SR, but I don't have the side SR. So what can I do? Well, I do have this side, which is 4 root 19. So 4 root 19 is opposite this angle here, angle SRQ. So what I could do is, because I have the side 4 root 19, I could work out this angle in the corner here, even though that's not what I need to do. But I could actually work that out, and that's what I'm going to do. So I pick an angle, so let's say it's 27 degrees, sine 27, over the side which is opposite to that, which is 9, equals sine of this angle here, okay, let's call this angle y, sine y, over the side which is opposite to that, which is 4 root 19. I can do a bit of rearranging. Okay, I can times the left-hand side by 4 root 19. So 4 root 19 times this fraction is equal to sine y. So all of this is equal to sine y. So if I want angle y, the opposite of sine y is to inverse sine. So if you press shift sine, you then have to type in everything that's here on the left-hand side in this bracket. Type in 4 root 19 multiplied by a fraction sine 27 close brackets over 9. Scroll to the right, close that. This is angle y now. So angle y is equal to 61 point, remember not to round this, 583, so on. Okay, but that's not the angle that I was asked to work out. I was asked to work out this one here. But now I know 2 of the angles inside the triangle, so I can work out the third one pretty easily by subtracting from 180. So if I do 180 minus 27 minus the answer that I've just worked out, this gives me a final answer of 91.46662, etc. Now, the size of angle SQR is what we're asked to work out, and I've just worked that out. That's 91.4. So there you go. 90. Let's round it. It will be 91.5. I'll copy that down. 90. Oh, sorry. 91.416. So 91.4. Oh my god. Okay, 91.4. There you go. Okay, for this question, what we need to do is use differentiation to find the value of b minus d. Now, there are very limited questions they can ask about differentiation in IGCSE maths. The questions will usually revolve around stationary points, and stationary points occur when the derivative is set equal to 0. And as you can see, we have a maximum point and a minimum point, and they are both types of stationary points. Stationary points occur when dy by dx equals 0. So first thing we do is figure out dy by dx, and then we'll set it equal to 0. So to differentiate, we end up with 3x squared minus 27. K is a number, so when you differentiate a number, it goes to 0. Okay, you cannot have the gradient. There's no gradient of just a number. It's flat. So set dy by dx equal to 0. As stationary points occur there, and then you need to solve this equation. Either you can divide it all by 3 to begin with, or rearrange it and then divide by 3 later on. I'll divide by 3 to begin with. 0 equals x squared minus 9. This is the difference of two squares, x plus 3, x minus 3. So when you solve this, what we do is we set each bracket equal to 0. So x plus 3 equals 0, x equals negative 3. And something similar for the other one, and you end up with x equals 3. Now it's quite clear to see that this one has an x coordinate of negative 3, and the other one has an x coordinate of 3. That means A is equal to negative 3. A is the x coordinate, B is the y coordinate, and here C is the x coordinate, and D is the y. Now the question is, how do you work out the y coordinate if you know the x coordinate? And the answer is you substitute it into the equation of the curve. So now we know x is negative 3, we can substitute it in here to work out the y coordinate, which they have called b. So like this, minus 3 cubed minus 27 times minus 3 plus k, minus 27 plus 81 plus k. So you end up with k plus 54. And that's what b is equal to. And then d, in a similar fashion, we have 3 cubed minus 27 times 3 plus k. So 27 minus 81 plus k. So k minus 54. And that's d. And the question asks us to work out b minus d. So it's b minus d. Now, this looks correct, but it's not, because minus applies to all of d, so you have to write it in brackets, then apply the minus to each term individually. Just imagine there's a negative 1 here, and so that will become negative k and then positive 54. So then if you compare this, if you simplify now, k minus k cancels, and you're left with 54 out of 54, which gives the final answer 108. Okay, so first of all, this question has been written using mapping notation. We're used to seeing the usual function notation, which is like this. So if you want to change it to begin with, so it's more familiar to you, that's absolutely fine. G of x is equal to x plus 1 over 2. They define h as fg, so composite functions. The way to work out composite functions is to write it as fg of x, right, square brackets around the second function, and then substitute g of x into these square brackets, so x plus 1 over 2. The next thing to do is to replace the x in f of x with your new x, which is x plus 1 over 2, like this. So at the top of the page we have 1 plus 1 over x, so it's 1 plus 1 over, and then it's x plus 1 over 2. Now, this term here, 1 plus x over 1, no, 1 plus x plus 1 over 2, it looks horrible because it's a fraction within a fraction. And the way that you deal with this is you times just this fraction here by the denominator of the fraction over the same thing. So like this, you times the top by 2 and you times the bottom by 2, just to this term here. Now, if you do that, the top becomes 2 and the bottom becomes, well, what happens is the divide by 2 cancels with this 2. So you're just left with x plus 1. Now, this is not so bad now. Okay, and you only need to do it to this fraction. And the reason that it's okay to do this is because multiplying by 2 over 2 is the same as multiplying by 1. And when you multiply something by 1, it has the same value. So we rewrite this as h of x, because that's what h of x is. Okay, fh is equal to fg, and now I've just worked at fg, so that's h. We're asked to work out the inverse function h. So what we do is, stage 1 is to write it as y equals. Stage 2 is to swap your x with y. Stage 3 is to try and make it y, trying to rearrange it to make y the subject. So let's shift the plus 1 to the other side. So on the right hand side, 2 is divided by y plus 1. So I can rearrange this as follows. We have x minus 1 multiplied by y plus 1 equals 2. This looks quite messy, but remember you're trying to make y the subject, so it's not a good idea to expand the brackets there. Let's just shift that to the other side. And finally, we take 1 from both sides to get rid of this 1 here. This is the final answer. We can write it on the answer line now. They have already written h minus 1 of x at the beginning, so we can just copy down the answer. Okay, next one. Okay, so expand the brackets. So if we expand the 2 brackets and then multiply by x, it's entirely up to you which order that you do this in. You may spot that this is the difference of 2 squares. So when you expand it, you end up with x squared plus x minus 1 plus x minus x cancels, so you end up with x squared minus 1. Then when you expand this bracket, you get x cubed minus x. Job done. Prove that the difference between a whole number and the cube of this number is always a multiple of 6. So it stems on from part A, you see. The difference, that's the negative, between the cube of this number, so x cubed, and the number x is always a multiple of 6. Right. So if we have a situation like this, you choose any number you like, let's say 3. 3 cubed minus 3 should always be in the 6 times table. So you have 27 minus 3, that's 24. 24 is in the 6 times table. Now, this is true. In fact, if you can try many examples, it will always be true. The answer will be in the 6 times table. But how can we prove this? Well, we need to take a look at how else we can write x cubed minus x. And you can rewrite it as x times x minus 1 times x plus 1. Now, if we write these in order, these 3 brackets, we have the smallest one, which is x minus 1. And then we have the next, which is x. And then we have the one after that, which is x plus 1. This is now in order, you see, from smallest to largest. And you can see when you look at these 3, that they are consecutive. You have a number, and then the next one is 1 higher than the previous one, and the next one is 1 higher than the previous one. So if you choose 3 numbers, like if this is 2, the next one will be 3, and the next one will be 4. And they're all times together. So if we have 2 times 3, 6, 6 times 4 is 24. So what's going to happen is the answer will always be in the 6 times table. But why is that? Well, you need to think about what happens. So if I just take a couple of examples, we've got 3 times 4 times 5. You can try this a few times if you like. You'll notice that every time you try this, at least one of your 2 numbers will be in the 2 times table. Because remember, these 3 numbers are consecutive. So if you have 3 consecutive numbers, at least one of them has to be in the 2 times table. So in the first example I gave, 2 of the numbers are in the 2 times table. In the second example, only one of the numbers is in the 2 times table, but still it will always be the case that at least one of the numbers will be in the 2 times table. Now, because these numbers are in order and they're consecutive and they're in groups of 3, one of the numbers must be in the 3 times table. It has to be the case. You won't get 2 numbers because they're in groups of 3, but one of the numbers will be in the 3 times table. And it's the fact that you have one of the numbers that's in the 2 times table and another one that's in the 3 times table, and you're multiplying them all together, which will give you a result which is in the 6 times table, because it's the 2 times table times the 3 times table. And that's what gives a result in the 6 times table. So a bit like this. One of the numbers is a multiple of 3. At least one of the numbers is a multiple of 2. Hence, the product is a multiple of 6. And there you go. That's fine. Right, this is quite a challenging question. Grade 9 at the end of the paper. A 3D shape consists of a hollow sphere made of metal. Now, you have to understand that this word hollow is very important, because it's a bit like if you think of a football. A football is made out of a certain material, but the inside of a football is air. And that's what you have to see when you look at the cross section of the sphere, that this is the material around the edge. It's been sliced down the middle. But inside, this is hollow, so this is just air in the middle here. Okay, so you just got to bear that in mind. The middle bit won't have mass. It's just this metal layer around the edge, and that's the bit that has mass. So bear all of that in mind. it tells you that this layer here has a density of 2,700 kilograms per meter cubed, and the mass of the 3D shape is 1,980 kilograms. So it talks about the density of the metal. So I really wish we had the volume of the metal, and we can work out the volume of the metal because we know the formula for the volume of a sphere is 4/3 pi r cubed. But you see, we have a sphere contained within a sphere. That's how you have to imagine this. So what I need to do is work out the volume of the big sphere and subtract the volume of the inner sphere of air, and then that will leave me with the volume of the metal. So it's a bit like this. Now I'm going to call the radius of the big sphere, well, it should be 1.2 plus t, but you have to be very careful here because you see t is in centimeters and the radius of the inner sphere is in centimeters. So what I'm going to do is introduce another letter. I'm going to call the radius of the big sphere r, capital R. So like this. I'm trying to work out the volume of metal now. So it's the big sphere, 4/3 pi r cubed minus the inner sphere, which is 4/3 pi times 1.2 cubed. Now this works out the volume of the metal. Okay. Now, what else do you know? You know the density of the metal, and you know the mass of the shape, the entire shape, but the inner sphere doesn't contain any mass. So this is fine. This is the mass of the metal. So the formula for density, don't move Vicky, dmv, have something like this. And what we can do is we're trying to work out what t is, and that's that missing part of the radius. So what I'm going to do is I'm going to set out the formula for volume. So the volume, which is actually this, so 4/3 pi r cubed minus 4/3 pi times 1.2 cubed is equal to mass, which is 1980, over density, which is 27. Right, so I need to do a bit of rearranging now. Okay, so all of this, take that to the other side where it's plus. So let's have a go. So 1980 over 2700 plus 4/3 pi 1.2 cubed. So this is so I end up with this. So I end up with what's left now is 4/3 pi capital R cubed is equal to 7.97. Okay, and you don't round yet. Pop it down the display. Okay. Try to work out R. So if you divide 7.97 by 4/3 pi, divide by 4/3 pi, you end up with capital R cubed equal to 1.90307, etc. So that means R is equal to the cube root of that. So shift to cube root and 1.239. Okay, so this is what capital R is equal to. I know that the inner R, the inner radius is 1.2. So if I subtract 1.2 from that, that will give me T. So this is 0.0392, etc. So this is T, but this is T in assuming T is in meters, because I've assumed that this capital R is in meters, just to keep it all consistent. So this is assuming that t is in meters. So this is correct if t was in meters, but t is not in meters, t is in centimeters. So I need to convert this to centimeters. And the way that you convert meters into centimeters is you times it by 100. So if we times this by 100, it becomes 3.92291, etc. And the question says, give your answer correct to two significant figures, so 3. The next question, work out the sum of the multiples of 3 between 1 and 1,000. So this means as follows. You have the first number in the 3 times table, which is 3, and then 6, and then 9, and then 12, and so on, all the way up to the highest number in the 3 times table in this list, which is 999. And what it's saying is, add all of these numbers together. Well, this is an arithmetic sequence. The first term is a. A is equal to 3. The common difference is also 3. And how many terms will there be? Well, if we think about it, you have the numbers from 1 to 1,000, and how many numbers in the 3 times table will there be between 1 and 1,000? Well, it's going up in threes. So if we divide 1,000 by 3, so 1,000 divided by 3, you get 333.3 recurring. And so there's only going to be actually 333 numbers between 1 and 1,000 that are in the 3 times table. 333 whole numbers. So n is 333. We can use the formula from the formula sheet, which is a half n, or n over 2, square brackets 2a plus n minus 1 d. So we have 333 over 2. We have 2 times 3 plus 332 n minus 1 times d. Okay, type this one into the calculator. So 333 over 2, open brackets, 6, 2 times 3 is 6, plus 332 times 3, close brackets, and we end up 166,833. 166,833. And that's the answer to the question.